areas and sectors. We're going to be answering the question, what is the relationship? So question number 88 says, to celebrate their victory, the girls' ice hockey team goes out for pizza. The goalie eats half of a pizza that has a diameter of 20 inches. What is the area of the pizza that she ate? And what is the length of the crust that she ate? Leave your answers in exact form. That is, leave your answer in terms of pi. Okay? So the first thing that you need to do is you need to take the diameter of her piece of pizza, which was 20, and figure out the radius. Radius is how much of the diameter? Half. So you just divide it by 2. So your radius is just going to be 10. We need the radius to plug into our formula, pi r squared. Okay? That's going to give you the area of the whole pizza. So if we plug in the 10, 10 squared is 100, and we get 100 pi. But the goalie ate half of the pizza. So if the whole pizza is 100 pi, half of the whole pizza is going to be 50 pi inches squared. And when they say to give your answer as exact, they mean to leave it just like this. If they tell you to write your answer as a decimal, then you punch it in the calculator using the pi button, hit the enter or the equal sign, and round to whatever decimal they tell you to round to. Okay? That's getting the area of the pizza. Now they want us to get the crust. For the crust, they just want just that little portion of the circumference. So the circumference formula is 2 pi r. So again, we plug in the 10, which is the radius. 2 times 10 is 20. So the circumference of the whole pizza is 20 pi, but we want half of it, so we divide it by 2, and that means it's 10 pi inches. Okay? Any questions on part A? All right, part B says Sonia chooses a slice from another pizza that has a diameter of 16 inches. If her slice has a central angle of 45 degrees, what is the area of her slice? What is the length of its crust? All right, so we're going to take the 45 degrees that they're telling us that this pizza is out of a total circle of 360, and we're going to reduce it. Just so happens that 45 goes evenly into both of those numbers. So this reduces to 1 out of 8, 1/8 of the pizza. Okay? Then we also know that this pizza has a diameter of 16 inches. So its radius is going to be half of that, which is 8. So I'm going to plug the 8 into the pi r squared formula. 8 squared is 64, so we get 64 pi. That's the whole pizza. We just want 1/8 of it, so we're going to take 1/8 of the 64 pi, and the piece that Sonia gets is 8 pi inches squared. Okay? Then we just want the crust, okay? So the crust is the circumference, so the 2 pi r, we plug in the radius of 8. 2 times 8 is 16, so we have 16 pi. That's the whole pizza. We just want 1/8 of it, or 45 out of 360. So we divide that by 8, and we're just getting 2 pi inches squared. Okay? Any questions on part B? All right. As the evening draws to a close, Sonia notices that there is only one slice of the goalie's pizza remaining. She estimates the central angle to be 72 degrees. Using this estimate, what is the area of the remaining slice and what is the length of its crust? Show how you calculated your answer. Hi. 72 degrees out of a total 360 degree pizza. So I'm going to take 72 out of 360, that reduces to 1/5. So 1/5 of the pizza. Again, its diameter was 20, so its radius is 10. So I'm going to square the 10 to get 100 pi, but I need 1/5 of that. So if I divide by 5, it's going to be 20 pi inches squared for the area of the pizza that's left. Then we want just the crust, so just the outline of it, which is the circumference. So 2 times the pi times 10 is 20 pi. We want just 1/5 of it, so we divide by 5, and we get 4 pi inches. Any questions on part C? Okay. Part D. A portion of a circle, like the crust of a slice of pizza, is called an arc. This is a set of connected points a fixed distance from the center point. The length of the arc is part of the circle's circumference. If a circle has a radius of 6, what is the length of an arc with a central angle of 30 degrees? Okay, so now we're getting to 30 degrees out of a total of 360. The radius is 12 times pi. Watch what happens when we type all of this into the calculator. We go 30 divided by 360. We're going to multiply that by 12. I'm in some weird mode. Hold on. We want normal here. Okay, now let's try it. 30 divided by 360. Still, okay, times 12. It's giving me a bunch of decimals, but it's 1. And then your calculator should have a pi button. So if you type pi, 1 times pi, you get, let's try that again, 3.14, which is what your approximate pi is equal to, okay? So sometimes they ask your answer in 2 different ways. If they ask for your answer in exact, they want you to leave it as pi. If they ask for your answer as a decimal, then you would type what we just saw on the calculator. The 3.14, blah, 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 okay? All right, part E says, then we're going to use the calculator button again. Part E, a region that resembles a slice of pizza is called a sector. It is bounded by 2 radii of a central angle and the arc between their endpoints on the circle. If a circle has a radius of 10 feet, what is the area of a sector with a central angle of 20 degrees? So this one we are going to change to a decimal. And I do want you to write down that you're going to use the pi button on your calculator. Let me switch to this calculator that's not in some weird mode. Okay, move it up just a tad. All right. Okay, so this sector is 20 degrees, so we're going to write 20 over 360. We know that the radius is 10, so 10 squared is 100 times pi, which is 100 pi. If we type in 20 times 100, divide it by 360, it's going to give us a decimal. Then we're going to multiply it by the pi button, so times the pi button. It's going to give us this decimal, 17.453. We're going to round it to approximately 17.5 units squared, okay? If you have your own scientific calculator, make sure you know where the pi button's at. If you don't have your own calculator, you're going to use the Desmos scientific calculator, and there are 2 options. You can either use the pi button there, or you can actually type in the letters PI, and it'll type the pi symbol for you. It's kind of a little shortcut. All right. Any questions on part C? Okay, I think we're done with pizza. All right. Question 89 says, it is useful to be able to calculate the area of the sector of any circle. Work with your team to derive a formula. Look at your work from problem 88 and describe the relationship between the area of the sector and the area of the full circle. Okay, what is the relationship? It's the fraction of whatever the whole circle is. If we take that angle measure, and they use this Greek letter symbol theta, out of 360, then you still end up multiplying it by the area of the circle, which is pi r squared. So two numbers get plugged in. The angle measure gets plugged in here, and the radius gets plugged in here. Remember, pi is just a number. So these are all numbers. Once you've plugged everything in, punch it in the calculator, it's going to spit out your answer and then round it to whatever decimal they ask you to round it to. All right, any questions on 89? All right, anybody still writing? No? Okay, flip over to the top of page 21, question number 90. Use the sectors in circle D and E to answer the following questions. What is the length of the marked arc for each circle? Leave your answers in exact form, meaning in terms of pi. So they don't want us to get a decimal answer. Just leave it in pi. Okay? So I did circle D first, and then I did circle E. Okay? Remember, this is the symbol for circle. So for circle D, we have an arc, or we have an angle measure of 30. So I did 30 out of 360. We have a radius of 3, so we plug a 3 in there. We multiply everything, and we get pi over 2 units. For circle E, we have an angle measure of 30, so 30 out of 360. We have a radius of 5, so we plug in the 5 here. We multiply everything but the pi button, and we get 5/6 pi units. Okay. Part B, for circle D, what is the ratio of the arc length to the radius? It's going to be a half of the third, so it's going to reduce to pi over 6. You're going to notice for part C, for circle E, what is the ratio of the arc length to the radius? Leave your answer in terms of pi. So it should be 5/6 pi, which was the answer, divided by 5, which would get us pi over 6. Notice that these two are the same. And then for part D, it says, suppose that it was 100 units and an arc of 30. So if the arc is, or if the angle is always 30, 30, 30, 30, your ratio is going to stay the same. It's going to be pi over 6, pi over 6, pi over 6. The only thing that's going to change is your radius, right? That leaves us with the last question, which says, there are other units of measure besides degrees that can be used to measure an angle. For example, the radian measure of a central angle is the ratio of the arc length to the radius of the circle. Why will all arcs with central angles of 30 degrees have the same radian measure? And that is that the ratio of the arc length to the radius is 1/12 times 2 pi, which is always pi over 6.